It's wonderful to have you here. Tonight, while the waking world settles into stillness, your mind is preparing to do something it cannot do while you watch it. It will close the door on this single, solid room and open 1,000 others, each one built from nothing. Each one felt as real as this. No light enters. No sound guides it. And yet, whole worlds arrive. That is where tonight begins. Close your eyes and breathe deeply. You're resting where particles refuse to choose one path. Let your mind stop choosing too. Welcome to Sleepy Science Facts. Tonight, as you drift towards sleep, your brain is preparing to become almost as active as it is right now. While you read these words, during the deepest dreaming, the sleeping brain burns nearly as much energy as the waking one. It builds landscapes, faces, conversation, and physics of its own, all without a single signal arriving from the outside world. There is no light reaching your eyes, no sound shaping the story, and still the experience feels complete. This is the quiet puzzle we will sit with tonight. Where does a world come from, when nothing is feeding it from outside? And why does that inner world feel every bit as real as this one? The dreaming state has a name and a discovery date. In 1953, two researchers named Eugene Aserinsky and Nathaniel Kleitman noticed that sleeping people's eyes sometimes darted rapidly beneath closed lids. They called it rapid eye movement sleep, or REM. When they woke sleepers during these bursts, the sleepers almost always reported vivid dreams. For the first time, the inner theater of the night had a measurable signature. The eyes moved as if watching something. The brain, it turned out, was wide awake in the dark, and the body, oddly, was held perfectly still while the mind ran free. There is a strange fact hidden inside every dream. The entire world you experience while dreaming is generated from within. Your eyes are closed. Your ears hear only the quiet of the room. And yet you walk through cities, speak with people, feel rain, taste fruit, and fear what chases you. The brain assembles all of it from memory, expectation, and electrical rhythm. It is, in the most literal sense, a reality made of nothing but you. Tonight's question begins here, in this quiet impossibility. How does a sealed mind, fed by no outside light, paint a world so convincing that you forget you are lying still in the dark? Dreams feel real for a reason rooted in the brain's anatomy. During REM sleep, the visual centers of the brain light up almost as they do when your eyes are open, painting images directly. At the same time, the prefrontal cortex, the region responsible for logic, doubt, and self-monitoring, grows quiet. With the critic asleep and the painter awake, the mind accepts whatever it sees. That is why a talking river or a familiar stranger raises no alarm inside the dream. The part of you that would normally say this cannot be has gently stepped away. What remains is pure experience, unquestioned. And that is part of what makes the dream feel more vivid than memory. Beneath the science of dreaming lies a question that science has never fully answered. It is called the hard problem of consciousness. we can map which neurons fire, which chemicals rise and fall, which regions glow during a dream. But none of that explains why there is an experience at all. Why the inside of your mind feels like something rather than nothing. A camera records light without seeing. A computer processes without feeling. Yet you, lying here, are aware. This gap between the machinery and the felt experience is one of the deepest open questions we have. And dreams sit right at its center. Experience without a world. For most of modern neuroscience, dreams have a practical explanation, and it is a beautiful one. While you sleep, the brain sorts through the day. It strengthens the memories worth keeping, loosens the ones it can release, and files experience into long-term storage. Dreams, in this view, are partly the felt side of that housekeeping. Fragments of memory being moved, compared, and woven together. This is the steady, well-supported understanding, and we will hold on to it tonight as our anchor. But notice what it does not quite explain. It tells us why the brain replays and recombines. It does not tell us why the replay feels like a place you can stand inside. One classic theory gives dreams their structure. In 1977, researchers proposed the activation synthesis idea. During REM, the brainstem sends out bursts of more or less random electrical signals. The higher brain, unwilling to face nonsense, weaves these signals into a story, the way you might find shapes in drifting clouds. In this view, the bizarre logic of dreams is simply the mind making narrative sense of noise. It is an elegant explanation, and much of it holds up. Yet even here, a quieter question lingers underneath. The mind does not merely label the noise. It renders it fully into sight and sound and feeling, as if building rather than guessing. Some features of dreams have always resisted easy explanation. The hyper-real detail of certain dreams. The sense, on waking, that you visited somewhere rather than imagined it. The recurring feeling that a dream knew something before you did. None of these prove anything beyond the ordinary workings of the brain. And most have gentle, classical explanations rooted in memory and emotion. But they are the reason humans have wondered, for as long as we have had language, whether the dreaming mind reaches somewhere the waking mind cannot. Tonight we hold that wondering lightly, neither believing it nor dismissing it, and we follow it toward the strangest corner of science. To follow that wondering, we have to leave the familiar scale of the world and travel downward, into the realm of the very small. Because down there, beneath molecules, beneath atoms, reality stops behaving the way it does in daylight. At the quantum scale, the smallest pieces of matter do not sit in one place, choose one path, or hold one fixed state. They hover among possibilities. They behave less like solid objects and more like clouds of maybe. This is not mysticism. It is the most precisely tested physics we have ever built. And its strangeness is the first thread we will hold as we ask what dreaming really is. Something has already shifted across these 10 facts. Not in the science, but in the frame. We began with a sealed mind painting a world from nothing. and we have arrived at a layer of reality where nothing sits in a single state until something looks. The resemblance is only a resemblance, a rhyme between two kinds of strangeness. And we should be careful not to mistake a rhyme for a bridge. But it is worth noticing. The waking world insists on one fixed reality: the dreaming mind, and the quantum scale beneath all things. Both quietly refuse that insistence. Tonight we sit in the space where those two refusals meet. The first pillar of quantum strangeness is called superposition. A single quantum particle, like an electron, does not have to be in one state or one place. Until it is measured, it exists in a blend of possibilities at once. A kind of and rather than either or. It is not that we are merely unsure which state it is in. As far as the best experiments can tell, it is genuinely in several at once, and only settles into one when observed. Hold that image gently. Before a question is asked, the answer is many. Only the asking makes it one. The dreaming mind, free of questions, may be the most multiple state we ever enter. There is a single experiment that captures all of this strangeness, and it has been performed countless times. It is called the double-slit experiment. Send particles one at a time toward a barrier with two narrow openings, and something impossible happens. Each particle, alone, behaves as if it passed through both slits at once, interfering with itself like overlapping ripples on water. The lone particle explores every path before arriving. But the moment you place a detector to watch which slit it uses, the dual behavior vanishes, and it picks just one. Observation changes the outcome. Reality, at this scale, seems to wait until it is watched before deciding what it was. The second pillar is even stranger, and it troubled Einstein himself. It is called entanglement. Two particles can become linked so deeply that measuring one instantly tells you about the other, no matter how far apart they are, across a room or, in principle, across a galaxy. Einstein called it spooky action at a distance, hoping it pointed to a flaw. But it is real. In 2022, the Nobel Prize in Physics honored experiments that confirmed it beyond reasonable doubt. Two pieces of reality, once joined, remain correlated as if distance means nothing to them. The universe, at its base, is woven together more intimately than the solid separateness of daylight suggests. With these phenomena comes a puzzle physics has never resolved, called the measurement problem. Before observation, a particle holds many possibilities. After observation, it holds one. But what counts as an observation? What, exactly, makes the cloud of maybe condense into a single fact? Is it the measuring device? The act of looking? The involvement of a conscious mind? Or simply contact with the wider world? Nearly a century of brilliant work has not settled it. This is one of the genuine open seams in our understanding of reality. And it is precisely the seam through which every speculation about dreams and quantum minds tries to slip. We will treat that seam honestly tonight, because the mathematics of quantum mechanics works perfectly while its meaning stays unsettled. Scientists have offered different stories to interpret it. These are called interpretations, and there are several. One says the possibilities simply collapse into one outcome when measured. Another says a hidden guiding wave steers the particle along a real path the whole time. Another, which we will meet next, says every possibility actually happens. What matters tonight is this. All of these interpretations agree with every experiment we have ever done. None has been proven over the others. So when anyone speaks of what quantum mechanics really means, they are choosing a story, not reporting a fact. Honesty asks us to remember which is which. One interpretation gives dreaming its most haunting metaphor. In 1957, a physicist named Hugh Everett proposed that the possibilities never collapse at all. Instead, every outcome happens, each in its own branch of reality. When a particle could go two ways, the world quietly divides, and a version of everything follows each path. This is the many worlds interpretation, and it is taken seriously by serious physicists. But it is an interpretation, not a measurement. No instrument has ever detected another branch, and by the theory's own logic, none ever could. So the idea of parallel realities, the very phrase, "the night seems to whisper," lives in mathematics and imagination, not yet in evidence. Now comes the fact that keeps all of this honest, and it is the most beautiful of all. It is called decoherence, superposition, the delicate state of being many at once, is extraordinarily fragile. The moment a quantum system touches its surroundings, air, heat, light, vibration, the surroundings effectively measure it, and the blend of possibilities collapses into ordinary, single-state reality. This happens almost unimaginably fast. Decoherence is the reason your coffee cup is in one place, the reason the waking world is solid and single. The quantum haze is real, but the world conspires, constantly and instantly, to hide it, to see it. Scientists isolate systems in extreme cold and stillness. Reality, left to itself, chooses. This is exactly why most physicists are skeptical that quantum strangeness plays any direct role in thought. The brain is warm. It is wet. It is electrically noisy, packed with jostling molecules at body temperature. By the standard physics of decoherence, any quantum superposition inside the brain should collapse in a tiny fraction of a second. Far too fast to matter for thoughts that take milliseconds to unfold. This is the central objection, and it deserves to be stated plainly rather than wished away. The honest starting position is doubt. If quantum effects shape the mind, they would have to survive an environment that destroys them almost everywhere else. That is a high bar. And yet there is one reason the question refuses to close completely. Biology has surprised us before. For a long time, scientists assumed living systems were far too warm and messy for quantum effects to matter at all. Then, over the past 2 decades, careful experiments began finding hints that nature, in a few special places, does seem to use quantum behavior, and use it well. None of this proves anything about dreams, but it cracks open a door that was once thought firmly shut. It suggests that warmth and wetness are not always a death sentence for the quantum world. Sometimes, in narrow and specific ways. Life appears to have learned to shelter the haze. To explore where such sheltering might happen in the brain, we have to look inside the cell, at structures called microtubules. Every cell in your body, including every neuron, is held together and organized by a skeleton, and microtubules are its main beams. They are tiny hollow tubes, far thinner than anything you could see, built from a protein called tubulin. They give cells their shape, act as highways for transport, and help cells divide. They are ordinary, vital, and everywhere. But because of their precise, repeating, crystalline structure, a few scientists have wondered whether they could do something far less ordinary, something at the edge of physics. We will meet that idea soon. The structure of a microtubule is worth picturing, because its order is the heart of the speculation. Tubulin proteins join in pairs, and those pairs stack into long, hollow cylinders arranged in a neat lattice, like bricks in a perfectly regular tower. This geometry is highly organized, almost crystal-like, and it repeats with great precision. In most discussions, microtubules simply do their structural and transport work, faithfully and without mystery. But order, at the smallest scales, is exactly what quantum coherence tends to need. Irregular, repeating, protected lattice is the kind of place where, in principle, delicate states might last a little longer than the warm chaos around them would normally allow. That, at least, is the proposal. There is one observation that keeps microtubules in the conversation about consciousness. General anesthetics, the drugs that switch off awareness for surgery, are still not fully understood in how they work. They reliably erase consciousness and then return it, like a dimmer switch on the self. Some research suggests that part of their action involves microtubules, subtly altering their behavior. This is studied, real, and genuinely interesting, though its full meaning is still debated. If the structures that anesthetics touch are tied to the presence or absence of awareness, then those structures sit close to the mystery of consciousness itself. It is a clue, not a conclusion, and we hold it as such. Behind dreaming lies another unsolved puzzle, called the binding problem. Your brain processes color in one region, motion in another, sound in another, meaning in yet another, all slightly separated in space and time. Yet your experience is seamless. You do not perceive color, then motion, then sound as separate streams. You perceive one unified moment. How the scattered activity of billions of neurons becomes a single, bound experience is not fully understood. And here is the quiet wonder. In dreams, with no outside world to organize it, the brain still produces this seamless unity, a whole coherent world, bound together from the inside, whatever binding is. Dreaming shows it running unsupervised. So consider what the dreaming brain accomplishes every single night. With no sensory input to lean on, it constructs a unified world, complete with space, time, characters, emotion, and a sense of self moving through it all. It solves the binding problem without help. It generates a reality that feels singular and continuous, even though it is assembled from scattered fragments. Whatever process unifies experience in waking life is running here too, in the dark, on its own. This does not require any exotic physics to be a wonder. The ordinary brain doing ordinary dreaming is already doing something we cannot fully explain. The mystery does not need quantum mechanics to be real. It is already here. 25 facts in, a pattern has emerged, though it is not the pattern we might have expected. We came looking for whether dreams reach other realities, and instead we have found two separate strangenesses standing side by side. On one side, a brain that builds whole convincing worlds from nothing, every night, by means we cannot fully explain. On the other, a physical reality that, at its smallest scale, genuinely refuses to settle into one fixed state until something interacts with it. Whether these two ever truly touch is exactly what the rest of tonight will follow. Slowly, without rushing to join them. We have not answered the question. We have only learned to ask it more carefully. That is where the next arc begins. Right now, in the quiet of your skull, billions of neurons are settling into slower rhythms than they held an hour ago. Not because you commanded them, because you stopped feeding them the demands of the day. The same brain that builds entire worlds in the dark is, at this moment, softening the borders of this one, the fixed, single, certain reality you carried all day is loosening its grip, just slightly, the way it must before a dream can begin. The question that just opened, whether the strangeness in you and the strangeness in matter ever meet, does not need an answer for you to rest. It only needs to be held lightly. Notice your breath. It is already moving you toward the place where the world stops being singular. Now we continue. The study of quantum effects in living things has a name now. It is called quantum biology, a young but serious field that grew up over the last 2 decades. For most of the 20th century, scientists agreed that life was far too warm and disordered for the delicate quantum world to play any meaningful role. Then better instruments let researchers look more closely at a few specific processes, and the old certainty softened. Quantum biology does not claim that life is fundamentally quantum in some sweeping way. It studies particular, narrow cases where the evidence suggests quantum behavior genuinely contributes. Those cases matter tonight, because they show what nature can hide inside warmth. The first and most studied example lives inside a leaf. When a plant captures sunlight, the energy has to travel through a maze of molecules to reach the place where it is stored. Studies of photosynthesis have found signs that this energy may, for a brief moment, explore several paths at once, in a quantum-like way, before settling on an efficient route. The exact extent of this effect, and how much it matters, is still debated among scientists, and the picture has grown more cautious over time. But the core finding stands as a hint. Inside something as common as a green leaf, the rules of the very small may leave a faint, fleeting fingerprint. The second example flies overhead each spring and fall. Migrating birds navigate using the Earth's magnetic field. And the leading explanation is strikingly quantum. In their eyes are proteins called cryptochromes. when light strikes them. It creates pairs of particles whose quantum spins are sensitive to magnetism. The faint magnetic field of the planet nudges these spins. And that nudge, scientists propose, becomes a kind of compass the bird can sense. This radical pair mechanism is one of the strongest cases in quantum biology. A living creature, warm and breathing, may be reading the sky through a quantum instrument grown inside its own body. Nature, it seems, found a use for the haze. The third example is happening inside you right now. The chemical reactions that keep you alive are sped along by enzymes. And some enzymes appear to use a quantum trick called tunneling. In the ordinary world, a ball cannot pass through a hill without enough energy to climb it. But a quantum particle, being a cloud of possibility, can sometimes simply appear on the far side, tunneling through a barrier it could not classically cross. Certain enzymes seem to let protons and electrons tunnel like this, making reactions faster than classical chemistry would allow. The metabolism warming your body as you rest may quietly depend on particles slipping through walls that should have stopped them. A fourth example remains genuinely controversial, and it is worth meeting honestly. There is a theory that our sense of smell may rely partly on quantum tunneling, that we detect not only a molecule's shape but the vibration of its bonds, sensed through electrons tunneling across them. Some experiments support it, others contradict it, and most scientists remain unconvinced. We include it not as a proven fact, but as an example of science in motion, where a bold quantum idea sits unresolved, neither confirmed nor dismissed. This is the honest texture of a frontier. Some ideas are firm, some are fragile, and a careful mind keeps them on different shelves rather than blending them into one comforting story. Step back, and these examples teach a single lesson, but it is a measured one. Warm, wet biology can, in a few special and narrow circumstances, shelter quantum effects long enough to put them to use. This does not overturn the physics of decoherence. The quantum haze still collapses almost everywhere, almost instantly. But nature appears to have found a handful of protected niches. In a leaf, in a bird's eye, in an enzyme's heart, where the haze lingers just long enough to matter. The lesson is not that life is quantum. The lesson is humility. The line between where quantum effects can and cannot reach turned out to be drawn in a slightly different place than we assumed. This is where microtubules re-enter the story, carried by that same humility. A small number of researchers, most prominently an anesthesiologist named Stuart Hameroff, have proposed that the highly ordered, repeating structure of microtubules might form one of those protected niches inside neurons. The idea is that their crystalline geometry could, in principle, shield delicate quantum states from the surrounding chaos a little longer than expected. It is worth being clear about the status of this claim. It is a proposal, a hypothesis built on possibility, not a demonstrated fact. But after seeing what leaves and birds can do, it is no longer an idea that can simply be laughed out of the room. It has to be weighed. Why microtubules, and not some other part of the cell? Part of the answer lies in their building block, the tubulin protein. Tubulin contains regions rich in certain electrons that can shift and respond in coordinated ways. In the speculative picture, these electron clouds, lined up along the regular lattice of the tube, could host quantum states that interact across the structure. This is the proposed mechanism, the imagined gear that would have to exist for the larger idea to work. Whether it truly does, at the scale and duration thought would require, has not been shown. But it gives the hypothesis something concrete to point at, a place where the very small might reach up toward the mind. In recent years, a handful of laboratory experiments have kept this thread alive, and they should be described carefully. Some studies have reported that microtubules can host unusual patterns of light and energy, behaviors that a few researchers interpret as signs of coordinated quantum activity. Others have explored how anesthetics interact with these structures in ways that might bear on consciousness. These results are early, preliminary, and contested. They are intriguing rather than decisive. The first faint marks on a map that is mostly still blank. Reporting them honestly means holding two things at once. The work is real and ongoing, and it has not, by any fair measure, settled the question one way or the other. One experiment in particular drew wide attention and deserves a careful telling. A few years ago, researchers used a modified brain scanning technique and reported a faint signal that, by one interpretation, could be a fingerprint of quantum entanglement at work in the living brain. If that interpretation held, it would be a startling clue. But the result is preliminary. The interpretation is only one of several possible, and it has not been independently confirmed in a way that satisfies the wider scientific community. It is exactly the kind of finding that excites headlines and demands patience in equal measure. Tonight we file it where it belongs, as a question mark rather than a period, a maybe rather than a yes. Why do findings like these stay unproven for so long? Because good science is slow on purpose. A single result, however striking, has to be repeated by other teams, in other labs, with other methods. Alternative explanations have to be ruled out one by one. And in this particular field, the great objection, decoherence, the speed at which warm environments destroy quantum states, never goes away. Each new hint must answer the same hard question. How could such a delicate effect survive long enough, at body temperature, to influence a thought until that question has a solid answer backed by repeatable evidence? The honest verdict remains open, not refuted, not confirmed, held patiently in the unknown. Here is the evidence checkpoint, the place to take stock of what these middle facts have shown. We can no longer say, with the old confidence, that quantum effects could never touch biology. The leaf, the bird, the enzyme have quietly proven otherwise. But we also cannot say that therefore the brain is quantum, or that dreams reach other realities. Those conclusions do not follow from the evidence. What we have is a softened boundary and a set of intriguing, unconfirmed clues. The careful position, the one a scientist would defend, is that the door is open a crack, and no one has yet seen clearly what lies behind it. That crack of openness is itself worth resting in. While the quantum question stays open, the ordinary neuroscience of dreaming has been quietly advancing, and it is rich. We now understand that REM sleep is deeply tied to memory and emotion. During these phases, the brain replays fragments of the day, strengthening some connections and weakening others. Emotional memories, in particular, seem to be processed and softened during dreaming, their sharp edges sanded down by morning. This is well supported, repeatable science, and it gives dreams a clear and gentle purpose. Whatever else they may or may not be, dreams are part of how the mind digests a life, sorting experience while the body lies still and safe in the dark. Dreams also appear to serve creativity, and this is more than folklore. Studies suggest that REM sleep helps the brain make unexpected connections, linking ideas that waking logic keeps in separate boxes. History is full of discoveries and melodies that arrived in dreams or in the drowsy moments beside them, and the science offers a reason. With the strict editor of the prefrontal cortex relaxed, the dreaming mind recombines memory freely, trying associations the waking mind would reject. This is why a problem you cannot solve at night sometimes answers itself by morning. The dream is not random play. It is the mind exploring its own combinations, in a state where nothing is forbidden and everything can be tried. 40 facts in, the picture has changed in a specific way worth naming. We arrived believing the brain was simply too warm for the quantum world to matter, and we leave knowing that warmth is not always the barrier we assumed. That single shift reframes everything that follows. It does not mean dreams are quantum. It means the old reason for dismissing the idea outright no longer holds. And so the question deserves to be examined rather than waved away. The evidence has not carried us across the river. It has only shown that the river is narrower than we thought. What waits on the far bank, if anything does, is where the second half moves. The night has carried you past the midpoint of the first half. The particles in everything around you, the air, the walls, your own resting body, are quietly humming with the same uncertainty we have been describing. Let the next stretch move through you slowly, like deep water finding its level. There is nothing to solve here, only to follow and to soften as we keep going gently into the dark. Now we can meet the idea this video was named for, by its proper name. It is called Orchestrated Objective Reduction, or ORC, O-R, proposed by the physicist Roger Penrose and the anesthesiologist Stuart Hameroff. In simple terms, it suggests that consciousness arises from quantum processes inside the microtubules of neurons, and that moments of conscious experience occur when these quantum states resolve, or reduce, in an orchestrated way. It is one of the boldest theories of mind ever offered, joining the deepest physics to the deepest mystery of awareness. It is also a minority hypothesis that most neuroscientists and physicists do not accept. We will explore it with both fascination and honesty, holding its beauty and its uncertainty together. To understand Orch OR, it helps to know what drew Penrose to it. He began not with biology but with a famous result in mathematics, Gödel's theorem, which shows that no fixed set of rules can prove every truth. From this, Penrose argued, controversially, that human understanding cannot be purely mechanical, purely a matter of following rules, the way a computer does. Something more, he reasoned, must be at work in the mind. That something, he proposed, might be rooted in physics we do not yet fully understand. Many philosophers and scientists dispute this leap, and the argument remains unsettled. But it explains why a mathematician went looking for the source of thought in the quantum foundations of the world. At the heart of Orch OR sits a piece of physics that Penrose himself proposed, and that has never been tested. He suggested that the collapse of a quantum superposition, the moment the cloud of possibility becomes one fact, is not triggered only by measurement or environment. Instead, he proposed that gravity itself causes collapse. Once a superposition grows large enough to matter to the structure of space-time, this is called objective reduction, because the collapse would be a real, objective event in nature rather than a matter of observation. It is an elegant idea that would tie consciousness to the deepest laws of the cosmos. It is also speculative, unconfirmed, and at the edge of known physics. Beautiful and unproven. How would such a thing connect to dreaming in the Orch OR picture? Each conscious moment corresponds to one of these orchestrated collapses inside the brain's microtubules, a kind of fundamental tick of awareness. In waking life, these moments are shaped and constrained by the steady stream of information arriving from the senses. But in dreams, that stream falls silent. The proposal, extended speculatively, is that the same process continues to run, now unanchored, free to follow its own internal currents without the world correcting it. In this view, dreaming would be consciousness operating in its purest, least constrained form. This is a what-if built upon a hypothesis, and we name it as such. A possibility stacked on a possibility. Against this beautiful structure stands a powerful objection. In the year 2000, the physicist Max Tegmark calculated how long a quantum state could survive inside the warm, wet brain before decoherence destroyed it. His answer was devastating to the theory. The states would collapse in something like a 10/trillionth of a second. While the brain's signaling unfolds over thousandths of a second, a gap of roughly 10 orders of magnitude. By this calculation, any quantum coherence in the brain would vanish far too quickly to shape a thought. This remains the central scientific reason most experts doubt Orch OR. It is the heart of the matter. The story does not end there, because the theory's defenders have answered, though not decisively. Hameroff and others argue that Tegmark modeled the wrong situation, and that the special structure of microtubules, perhaps with ordered water inside them or particular protected arrangements, could shield quantum states far longer than his calculation assumed. They point to the surprises of quantum biology as reason to think the brain might have its own protected niche. Critics respond that these defenses are speculative and unproven, and so the debate continues, unresolved. A genuine scientific disagreement rather than a settled question. We are standing inside an open argument, not reciting a closed conclusion. That, too, is part of the truth of tonight. Suppose, for a moment, that the bold version turned out to be true. What would it mean? It would mean consciousness is not merely computation. not just patterns of neurons firing like switches in a machine. It would mean awareness is woven into the fundamental fabric of physics, arising wherever the quantum and the gravitational meet under the right orchestration. The implications would reach far beyond dreaming, touching what we are and how mind relates to matter at the deepest level. This is the grand prize that keeps the hypothesis alive despite its troubles. The reward, if it were ever confirmed, would be enormous. But the size of a prize is never evidence that it can be won. And what would it mean for dreams? Under that same large supposition, dreams would become the mind running its deepest process without the leash of the senses. Awareness, exploring its own space, free of the world's constant correction. The vividness, the strange logic, the sense of visiting somewhere real, might all be the signature of consciousness in its rawest mode. This is the most evocative reading the night offers, and also the most speculative. We can feel its pull while keeping our footing. It is a story that would, if true, dignify the strangeness of dreams. But a story's beauty is a reason to examine it, never a reason to believe it. We hold the wonder and the caution together. Now we reach the most honest moment in the whole journey, the one that gives the title its true shape. For dreams to literally touch other realities, two unproven ideas would both have to be true at once. First, the many worlds interpretation, the notion that parallel branches genuinely exist. Second, Orch OR, the notion that the brain uses quantum collapse to think. Each is a serious idea held by serious people, and each is unproven. Stacking them does not add their strength. It multiplies their uncertainty. The popular image of the dreaming mind sliding between parallel worlds rests on this double speculation. It is a gorgeous idea. And as far as evidence goes, it is a poem rather than a proof. Look back now, and the question has changed shape since we began. We started by asking whether we travel between realities when we close our eyes. We can already see the form of the honest answer, even before the details fill in. The physics that lets reality stay open, and many at the smallest scale, is real. The brain that builds whole worlds in the dark is real. But the bridge between them, the claim that one explains the other, is not established, and may never be. The deeper tension is this. We are drawn to the grandest explanation precisely where the evidence is thinnest. What follows tonight moves into that tension, gently, toward what we can actually say. What just opened? The gap between the world we can imagine and the world we can prove is not only a question about physics. You may be carrying it right now, in a quieter form. The wish for a single, certain answer. The pull toward the largest, most beautiful explanation. The discomfort of not yet knowing. That discomfort is not a failure of understanding. It is the honest edge of knowledge, the place where every real frontier sits. Notice your breath. Notice that it keeps moving, steady and unhurried, even while the biggest question stays open. You do not have to close it tonight. You only have to let it rest beside you. Now we continue. Let us look more carefully at what reality means in quantum physics, because the popular phrasing misleads. The quantum description of a system is not a list of where things are. It is a wave function, a mathematical object holding all the possibilities and their likelihoods. Before measurement, the system is the whole spread of potential facts, not one. When we observe, we find a single outcome drawn from that spread. So the deepest layer of reality is not a collection of definite things. It is a landscape of possibility, waiting to be pinned into the single world we wake to. There is a precise rule for how possibility becomes outcome, and it is humbling. It is called the Born rule, and it lets physicists calculate the probability of each result from the wave function. The mathematics is exact, among the most accurate predictions science has ever made. And yet, for any single event, we observe only one outcome. The other possibilities, whatever their status, never appear in our records. We compute the spread of maybes flawlessly, and we witness exactly one. This is the strange contract of quantum physics. Perfect prediction of probabilities paired with a single lived result. We are always given the menu, and we always eat one dish. Return to many worlds, and look at it soberly. The interpretation says all outcomes happen, each in its own branch, making the result we see merely the one ourself rode along. The mathematics is clean and needs no extra machinery, which is why many physicists favor it. But here is the quiet catch. By the theory's own design, the other branches cannot be observed, contacted, or visited. They are walled off completely. So even if many worlds were true, it would not be a network of places a dreaming mind could wander into. The parallel realities, if they exist, are not destination. This lets us say something clear about dreams at last. Dreams are not evidence of other worlds, because we already have a sufficient explanation for them. Every element of a dream traces to your own memory, your own neural activity, your own emotional life. The faces are faces you have seen. The places are stitched from places you have been. The impossible logic is a brain running without its editor. We do not need parallel universes to account for any of it. And in science, when a simpler explanation covers the facts, we do not reach for a grander one. The dream is yours, sufficient unto itself. But if dreams are made entirely of you, why do they feel otherworldly? The answer lies in how the brain models reality. Awake, your inner model is constantly corrected by the senses, kept honest by the world. In dreams, that correction is gone, so the model runs free, untethered from any outside check. What you experience is your own reality engine running without its usual brakes. It feels foreign because, in a sense, it is a world built by you, but not bound by the rules you live under by day. The strangeness is not a doorway elsewhere. It is a mind modeling reality with the senses switched off. A specific network in the brain helps explain the dreaming self. It is called the default mode network, a set of regions that grow active when the mind turns inward, away from the outside world. It is the source of daydreams, of inner narrative, of imagining yourself in other times and places. In sleep, this inward-turning machinery feeds the dream's storytelling, generating the sense of a self moving through events. The same network that lets you awake, rehearse a conversation that never happened, helps build the cast and plot of the night. Your dreams have an author, and the author is a circuit you carry everywhere, even into the dark. The raw material of dreams is memory, recombined. The brain does not store experience like a film to be replayed whole. It keeps fragments, scattered across many regions, and reassembles them as needed. In dreaming, this reassembly runs loose. Pieces of different days, different people, different feelings are spliced into scenes that never occurred. This is why a dream can place a childhood home on a street you walked last week, peopled by a friend wearing a stranger's face. It is not a glimpse of another reality. It is your own library, shuffled by a hand that does not mind the catalogue, making combinations new because nothing forbids them. There is a tender purpose woven into REM dreaming, and the science is warm. During this stage, the brain processes emotional memory in a uniquely gentle chemical state. The stress chemical norepinephrine, which carries the feeling of alarm, drops to its lowest level of the entire day-night cycle during REM, so the mind can revisit difficult or charged memories without the full sting of stress attached. Some researchers describe this as a kind of overnight therapy, a chance to process the weight of experience in a safer chemical climate. The dream may feel chaotic, but underneath, something steady and kind is at work, softening what the day made sharp. One extraordinary state blurs the line between dreaming and waking, and it has been confirmed in the laboratory. It is called lucid dreaming. When the dreamer becomes aware, they are dreaming and can sometimes shape it. Brain scans show that during lucid dreams, parts of the prefrontal cortex, the region that goes quiet in ordinary dreams, partially switch back on. Sleep scientists have even communicated with lucid dreamers in real time, asking them to signal with deliberate eye movements from inside the dream. This is a genuine, repeatable phenomenon. It shows the dreaming mind can hold a quiet observer, awake within the dream. Time itself bends inside dreams, but not in the way physics means. A dream that feels like hours may unfold in minutes of clock time, and a long narrative can compress into a brief stretch of sleep. This is a property of perception, of how the brain stamps events with a sense of duration, not a property of space-time. Your dreaming mind is not slowing time or stepping outside it. It generates the experience of time from within, and that experience can stretch or shrink free of any clock. The feeling of a whole evening lived in a few minutes is the mind's timekeeping, unmoored. Consider the observer in your dreams. There is a you who watches, and often a you who acts, sometimes surprised by your own dream self's choices. This doubled presence, witness and participant, echoes the binding problem and the puzzle of the self. Awake. The unified sense of being someone is held together by the steady input of body and world. In dreams, that self is generated entirely from within, and yet it persists, coherent enough to feel like you. Whatever produces the experience of being a single observer runs here too, in the dark. The dreamer is proof that the self is something the brain makes, Modern neuroscience increasingly describes the brain as a prediction machine, and this reframes dreams beautifully. Rather than passively receiving the world, the brain constantly generates expectations and checks them against incoming signals, updating as it goes. Perception, in this view, is controlled prediction. Dreaming, then, might be prediction with the checking turned off, the brain running its model with no sensory data to correct it. The dream is what the prediction engine produces when it has only itself to listen to. Notice that this respected framework needs no quantum mechanics at all. The strangeness falls out of a brain doing, unsupervised, what it does all day. So why does the quantum metaphor feel so fitting? If dreams are explained without it, because both dreams and quantum physics dissolve the same comforting assumption, that of a single, fixed, observer-independent world. In quantum physics, reality stays open until interaction pins it down. In dreams, reality is fluid, multiple, answerable only to the mind that makes it. The two share a family resemblance, a kinship of strangeness, and the human mind delights in such rhymes. But a rhyme between two mysteries is not a mechanism connecting them. We can enjoy the resonance and still keep clear that it is a feeling in us, not a wire between the things. There is a real and respected field that uses quantum mathematics to study the mind, often misunderstood. So let us be precise. It is called quantum cognition. It applies the mathematics of quantum probability, not quantum physics in the brain, to model how people actually decide, judge, and remember, especially when our choices break the rules of ordinary logic. The formalism captures certain quirks of human thinking well. But, and this is the heart of it, quantum cognition makes no claim that the brain is a quantum computer. It borrows the math as a tool, useful equations, not physical quantum minds. 65 facts in. The pattern across the second half is clear, and it is not the one the title promised. The honest center of this subject is neither a hidden yes nor a flat no. It lives in the space between a metaphor that genuinely illuminates and a mechanism that remains unproven. The quantum world really is open and uncertain. The dreaming brain really does build worlds from within, and the connection between them is real as poetry, unestablished as physics. The big idea is almost visible now, and it is gentler than a grand revelation. The final stretch carries it toward what we can simply feel. One firm law of physics quietly closes the most tempting door, and it is worth knowing for the peace it brings. Even where entanglement is real, it cannot be used to send a signal or transfer information faster than light. The correlations are there, but they carry no message. So even if the brain did harbor genuine entanglement, it could not be a channel for visiting or receiving from other places or other realities. The universe's own rules forbid that traffic. The science fiction image of the mind tuning into elsewhere through quantum links runs into a wall built by physics itself. Entanglement offers connection without communication. Here is a gentle reversal worth holding. Decoherence, the very thing that defeats quantum dreams, is also a gift. It is the reason you have a stable, single world to wake into each morning. If superpositions did not collapse, reality would be an unlivable blur of overlapping maybes. The fast, relentless collapse of the quantum haze gives you one solid floor, one clear sky, one continuous self. The brain, too, leans on this classical stability to think reliably. So the same physics that makes the romantic version of dreaming unlikely is the physics that makes a coherent life possible. What the night cannot have is what the day depends on. At the scale where neurons actually do their work, the story is reassuringly classical, and there is comfort in that solidity. A neuron signals by moving charged atoms across its membrane, building an electrical pulse that travels and triggers the next cell. These action potentials are the language of the brain, well described by ordinary physics and chemistry. No quantum mystery required. Billions of them, firing in patterns, produce everything you think and dream. Whatever exotic physics might whisper beneath, the conversation between neurons that builds your nightly worlds is, as far as we can tell, beautifully classical. Where might quantum effects plausibly matter in the brain? In the most modest version of the claim, perhaps in the tiny, fast events inside single molecules. The gating of an ion channel, the flip of a protein, the tunneling of a particle in a reaction. These are small, local, and brief. The leap from such micro-events to the grand sweep of conscious thought is enormous, and no one has shown how to make it. The modest possibility is real and worth studying. The grand possibility is unproven and may be unreachable. Keeping the two apart is most of what honest thinking here requires. The deepest obstacle has a name we can now state plainly: the scale problem. Even granting brief quantum events at the molecular level, no one has shown how they could add up, coordinate, and persist to shape something as large and slow as a thought or a dream. Molecular quantum events last fractions of a trillionth of a second. Thoughts unfold over tenths of seconds. A chasm of about 10 orders of magnitude. The same gap Tegmark pointed to. Crossing it is the unsolved problem at the center of every quantum mind theory. Until someone bridges that chasm with evidence, the connection stays a hope held over an abyss. For any of this to be science rather than story, it has to make testable predictions. And to its credit, the field is beginning to try. Researchers have proposed experiments, such as testing whether subtle changes to the atoms in anesthetic molecules alter their effect on consciousness, or probing microtubules directly for signs of coherence. These tests are difficult, and their results so far are preliminary and debated. But proposing them moves the idea from pure speculation toward territory where it can be checked, confirmed, or ruled out. That is how a frontier matures, by being slowly put to the question that nature alone can answer. The most recent years have brought new experiments that keep the question warm without settling it, and they ask for the same patience. Some studies of microtubules and anesthetics report intriguing effects that a few researchers read as supportive of quantum processes in the brain. Others find no such thing, or offer ordinary explanations. The body of evidence, taken honestly, points in no single direction yet. It is a field in motion, each year adding a few brush strokes to a picture still mostly unpainted. Reporting it faithfully means resisting the pull to declare a winner. The truthful word, still, is that we do not yet know. There is a quiet strength in being able to say, simply, that we do not know. It is not a failure of science. It is its most honest and most powerful position, the stance from which every real discovery has eventually grown. The questions we cannot yet answer mark exactly where the edge of human understanding lies tonight. And that edge moves outward year by year. To rest in not knowing is not to give up. It is to hold the question open, with respect, while the slow work continues. The mystery of how mind arises from matter, and what dreams truly are, sits at that edge now. While the grand questions stay open, let us not lose the solid ground we do have, because it is rich and restorative. Dreams reliably help consolidate memory, fixing the worth keeping into lasting form. They help regulate emotion, processing the day's feelings in a gentler chemical climate. They let the mind simulate, rehearse, and imagine, trying futures and recombining the past. And they fuel creativity, linking ideas that waking logic keeps apart. These are not speculations. They are well-supported findings, the dependable gifts the night gives every time you sleep. Whatever else dreaming may secretly be, it is certainly this, a nightly act of care, asking nothing of you but rest. 75 facts in. The big idea can now be stated clearly. In its full intellectual form, two things are true at once. The physics that lets reality remain open, uncertain, and many at the smallest scale is real and confirmed. And the brain that builds whole, vivid, unified worlds in the dark, every night, by means we cannot fully explain, is real and ordinary. Whether these two strangenesses ever actually meet, whether the quantum world reaches up to shape the dreaming mind, is not established, and may lie beyond our reach. The remaining facts set the arguments down, and turn toward what all of this feels like. Every night, without instruction, the chemistry of your brain follows a cycle older than any worry you have ever held. The stress chemical that carries alarm falls to its lowest point. The rhythms slow. The doors between this world and the dream world begin, quietly, to open. Not because you arranged it, because the body runs on a clock that does not wait for permission. Right now, that cycle is turning in you. The same process that will soon build a world from nothing is already gathering, in the dark behind your eyes. The facts that remain do not need to be understood. They only need to arrive at the place you are already drifting toward. We're almost there. The brain at rest is never truly idle. Even now, as the day's demands fall away. It is not switching off, but turning inward, beginning to build. The same organ that solved problems and carried worries all day is preparing to become a maker of worlds. Rest, for the brain, is not emptiness. It is a change of work, from facing outward to creating from within. You have already dreamed thousands of nights in your life, and you remember almost none of them. Each one was a whole world, complete and felt, and then released by morning. The building does not depend on your memory of it. Night after night, the worlds arrive and dissolve, whether or not you ever know they came. The work continues regardless of your witness. Most dreams are forgotten within minutes of waking, and this is not a loss, but a tide. The chemistry that would fix them into memory is low during sleep, so the worlds slip away like water drawn back from sand. What stays is rarely the story, only a feeling, a color, a trace. The forgetting is part of the design, gentle and complete. In a dream, you are author, actor, and audience all at once. You write the story without knowing the ending, play a part within it, and watch it unfold as if it were happening to you. This single self, split into many roles and still feeling like one, is among the quiet wonders of the mind. You contain the whole theater, stage and player and watcher together. Superposition, the quantum state of holding many possibilities at once, has a gentle echo in experience. There are moments before a choice, before a word, before sleep, when many futures feel open at the same time. Dreams may be the closest the mind comes to that openness, holding many threads without resolving them. Tonight, you do not have to choose. You can let the possibilities stay many. Each morning, the single world reassembles itself around you. The dream's open landscape collapses into one bed, one room, one waking life. It is a small, daily echo of what physics describes. Possibility settling into fact the moment the world comes into contact with you again. Waking is a kind of gentle collapse. The many becoming one. The dream becoming a memory of a memory. There is comfort in this, if you let it settle. Not every door needs to be opened to be real to you. The dream you will not remember still happened. The possibilities you will not live are still, in some quiet sense, part of the field you move through. You do not have to resolve everything to rest. Some things can stay open, and the openness itself can be a place of peace. Entanglement, the deep correlation between distant things, is only a metaphor for human connection, and we should hold it as no more than that. But the feeling it points to is real. We are bound to people across distance, shaped by them whether near or far, carrying them in us through any separation. The physics does not reach into our lives that way. The felt connection, though, needs no physics to be true. In dreams, you sometimes meet other versions of yourself, selves who make choices you never would, who feel what you keep hidden, who live the lives you set aside. This is not a literal multiverse. It is a kind of inner one, the mind exploring its own unlived possibilities while you sleep. The dream lets you visit the people you might have been, gently, and return. One theory proposes that dreams are rehearsal, a safe place to practice. The mind may simulate threats so it can meet them better awake, or replay social moments to prepare for the next. In the protected dark, with the body still and safe, you run the drills of being alive without any risk. The dream is a quiet gymnasium for the soul, practicing the difficult things. Children dream differently than adults, and their dreams grow as they do. The youngest minds seem to dream in simpler forms, and as the brain develops, the worlds of the night grow richer, longer, more peopled and strange. Dreaming is not a fixed thing, but a capacity that matures alongside us. Each of us learned to build these worlds slowly, over years, without ever being taught. You are not the only creature that dreams. Studies of rats have shown that as they sleep, their brains replay the paths they ran while awake, the same patterns firing in the same order, as if they were running the maze again in the dark. Many animals appear to dream in their own ways. The building of inner worlds at night may be something life learned long before we did. Every human being, in every place and every age, enters this state. Each night, billions of minds let go of the single solid world and slip into worlds of their own making. It is one of the most universal things we do, and one of the most private. No one can ever enter your dream, and you can never fully share it. Yet all of us, together, do this same quiet thing. A dream needs no audience and no proof to be fully real as an experience. While it is happening, it is the only world there is, complete and convincing, asking nothing from the outside to justify it. Whatever it is made of, whatever it does or does not connect to, the dream is real in the only way that matters, from the inside. It is felt, and what is felt was real to feel. The worlds you visit each night are real as experience, even if they map to no place on any chart, even if they touch no other reality but your own. That is the gentler truth beneath the grand question. You do not travel to other worlds when you close your eyes. You build them from yourself, and you live inside them, and they are no less real for being yours. The wonder was never out there. It was always in the building. You can let go now of needing the answer. The question of whether the quantum world and the dreaming mind ever truly meet can stay open, unforced, and lose none of its beauty for staying so. Some questions are not meant to be closed, but to be carried, lightly, like a stone smoothed by holding. Tonight, you can set even that down. The not knowing can rest beside you, quiet and undemanding. While all of this turns in the mind, the body keeps its own simple work. Breath rises and falls. The heart slows. Tissues repair. The day's wear quietly mended in the dark. You do not have to manage any of it. The body knows the way to rest as surely as the brain knows the way to dream. Both are happening now, without your effort, beneath your awareness. Each night, the mind is willing to dissolve the fixed, single world it defended all day, and to let reality become fluid and many again. This nightly letting go is a kind of practice, a rehearsal of release that you perform without trying. The grip loosens. The certain becomes uncertain. And in that loosening, rest arrives. You have done this every night of your life, and you know how, even now. What you carry out of a dream is almost never a fact. It is a feeling, a mood that lingers into morning, a softness or a sweetness or a quiet ache with no clear cause. The story dissolves, but the feeling stays a little while. This is the dream's true gift. Not information, but tone. The emotional weather of the night, settling gently into the first hours of the day. The dark is not empty. It is where the worlds are made. All night, in the deepest stillness, the mind is at its most creative, building from nothing, asking for nothing. What looks like the absence of everything is inside you, the presence of creation. The darkness behind your closed eyes is not a void to fear. It is a workshop, warm and quiet, where you are always welcome. The smallest things in the universe refuse to be pinned to a single state until the world insists. Tonight, you are allowed to be a little like them. Unpinned, unmeasured, not yet decided into any single shape. Sleep is the one place you do not have to be one fixed thing. You can drift among possibilities, owing the day no answer, owing the world no proof of who you are. There is no measurement tonight, nothing being asked of you, no choice that must collapse into one. You can stop deciding. You can let the cloud of maybe stay a cloud. The mind that spent all day pinning things down can release its grip and let the possibilities hover. No observer is waiting. No outcome is required. Only the soft, open state that comes before anything has to become one. The single thread of your breath is the only anchor you need now. Everything else can become uncertain, can drift and dissolve and rearrange itself into dreams. The breath stays, steady and quiet, moving on its own. Let it be the one fixed point in a softening world, the gentle rhythm that carries you down. You do not have to hold it. It holds you. Whatever dreams come tonight, they belong to you alone. No one else can enter them, and you owe no one an account of where you go. They are the most private country there is, built by you, for you, dissolving by morning into nothing anyone else will ever see. Tonight's worlds are yours. Walk through them gently, or do not walk at all. Either way, they are home. The answer was never in the physics. It is in this. Something in you builds a world from nothing every single night and asks for no proof, no measurement, no other reality to make it real. The mystery was not whether you travel elsewhere. The mystery is that you create, in the dark, without trying, without needing to be told how. You are already the strangeness you went looking for. And now, you can let it carry you down into sleep. The mind was building worlds long before you wondered what they were made of. Every night, whether you trusted it or not, the stress chemistry fell away. The senses went quiet. And from your own scattered memory, a whole reality assembled itself in the dark. We went searching at the smallest scale of physics, where reality stays open and many until something looks, and we found a resemblance there. A rhyme between the uncertainty of matter and the fluidity of dreams. But the worlds you enter each night were always yours, built from within, sufficient and complete. The wonder was never somewhere else. It was in the Maker, working quietly behind your closed eyes. What you carry out of tonight is not a verdict on quantum minds or parallel worlds. It is the quieter recognition that something in you creates. Every night, from nothing, and needs no proof to make it real. The strangeness you went looking for was always already yours. Perhaps tonight you found a little ease in not needing the grandest answer, in letting a beautiful question stay open. A gentle like, subscribe, or share helps another restless mind find this same quiet place, where curiosity softens into sleep instead of keeping you awake. One quiet tap, one sleepy soul at a time. Right now, behind your closed eyes, the dark is not empty. It is gathering, the way it does every night, preparing to build a world you will not have to design. The senses are letting go of the room. The chemistry that carries the day's alarm is sinking toward its floor. The single, solid reality you held all day is loosening, becoming soft and open and many. Let your entire being dissolve into that opening. You do not have to make anything happen. The maker in you already knows the way, and it has never once needed your instruction. You can let these last thoughts drift apart now, like a cloud of possibility that no longer needs to settle into any single shape. Let your breath find the slow, unhurried pace that belongs to the dark. Sleep carries you toward the place where reality becomes fluid again, where worlds assemble from nothing and ask nothing of you in return. When you are ready for the next quiet question, more of these gentle facts are waiting for you in the description below, whenever you choose to come back. But if your eyes are closed, stay there. Rest well. Quiet one. Something in you has always known how to build a world from the dark, and it is beginning now, without any effort from you, where science becomes the softest place to rest. Good night.